different way, what would a ratio be in terms of a math thing? I guess what a ratio is. What does it look like? Okay, 3 to 1. Okay, you're saying 3 to 1 like this. A comparison. The 2 dot thing. And what's the other one then? Fraction. Ratio, like you were just saying, ratio is just a comparison of numbers by division. That's all it is. A ratio is a comparison of 2 things by division. The ratio is a comparison of things by division. That's really easy. 5, 6, 7, 8, 10, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. That'll be 23 or so. And then that'll be 13, 14 guys. Right, it would be 23 to 14. It would be 23 to 14 if you look at it in terms of the ratio. Now, since, and I'm going to do it this way, since Sophie's outside, technically we can't count her. So in the room right now, there's 22 to 14. Okay. Now, whenever you write out a fraction, what do you always do? What do you always do to that then? So whenever you have a fraction, especially with ratios, when we take the original ratio, 22 to 14, you just automatically simplify it. Hold on a second. And that would be considered, you know what that's called then when you simplify a fraction out with a ratio? It's simplified, but you know what that's called in terms of ratios? This then is called a scale factor. You've heard that before, right? Like models, have you ever built like a model car? It's like a 1/8 model or 1/16 model or something like that. That's what that means. So it's 1/8 the size, and so on and so on. This chapter doesn't really go into too much about scale factor. We'll see that again when we get into areas and volumes and stuff, because we talk about ratios of sides to their perimeters, to their areas, to their volumes. There's all this crazy math stuff that happens when you get into that. But right now, if you see the term scale factor, that's just what that means. It's just a simplified ratio. Okay? And what's nice is that because if you have this calculator, you type in 22 over 14 and hit enter, it does. Does it for you. That calculator is your friend. Okay. Like I said, I know you've seen this. One of the things you do have to make sure when you talk about ratios, they have to be in the same units. In order to compare two values, they have to be, just a lot of times they'll change the units on you. They'll do like centimeters to meters, or centimeters, millimeters, inches to feet, things like that. I've never been a huge fan of, all right, my wife's going to brain me for saying this. I don't like the metric system. I think it's stupid. I know it makes a lot of sense. Base 10, you can do all that kind of stuff for it. But I don't know what like 12 grams weighs. I can say, 12 ounces or something, or 32 ounces. That's like 4 cans of pop or whatever. You can figure that out. You can know that a gallon of milk weighs so much. You know what that feels like. I don't pick up a kiloliter of milk. So things that I'm going to make sure you guys remember: inches, feet, yards, and miles. The textbook will, from time to time, switch. I got an example here in a second that does go from centimeters and millimeters, and I'll show you how to work all that. But anytime I do, like, if I do quizzes and tests and I throw in units on you, if I do switch units, I'm only going to use inches, feet, yards, and miles. So just a quick reminder: how many inches are in a feet? In a foot? There's 12 inches in 1 foot. How many feet are in a yard? 3 feet in a yard. Okay. How many feet are in a mile? 5,280. Very good. So, to be honest with you, those are usually the only ones I'm going to worry about. I don't really get into ounces and gallons and all that. I'm usually just talking dimensions as far as inches and feet stuff. I try not to mix too much. What's that? What about what? Did I forget one?
Like yards.
Oh, you don't have to go yards. Normally, you don't go yards to miles. What you would do if you wanted to figure out how many yards were in a mile, if you know that there's 5,200 feet in it, what do you do to that to figure out how many yards there are? Just divide by 3. See what I'm saying? What is it, 1760? So, for example, if I want to look at 7 centimeters to 14 millimeters, if I wanted to talk about that ratio, if I wanted to write it out, it's one thing I want you to remember: it's always easier to use the smaller of the 2 units, because then you don't have to worry about dividing. You don't have to worry about getting a decimal or a fraction. Remember how many centimeters are in, or how many millimeters are in a centimeter? There's 10. That's one nice thing about it. I'll say that's base 10 stuff. Just count. So I would multiply the centimeters by 10, and I get how much? 70. So when I write that out, to simplify it, it'd be 70. Throw it in the calculator, what do you get? What do you get? 5. Now, when you're talking about a ratio, if you put that in the calculator, it will come out as 5. But ratio is a comparison of 2 things. So what do you have to put the 5 over? The 1. The ratio would be called 5 to 1. Does that make sense? I think you probably have seen that before. You just got to be careful when you're talking about ratios if you're rewriting them out. Am I going to absolutely yell at you and scold at you for forgetting to put units on something?
Yes.
I'm pretty bad about it. I usually forget. I'll become more of a pain, more so than normal, when we get to areas and stuff like that about labeling. For now, it's really not the end of the world. Ooh, extended ratios. The other one that's in here is something called another thing in here is something that's called an extended ratio. An extended ratio. An extended ratio just means that instead of looking at 2 things, you're looking at, well, more than 2. That same ratio applies to more than 2 things in this case in a triangle. So what they're saying is that you've got 3 angles in a triangle that have a ratio of 5 to 9 to 16. Well, the way that this works is pretty easy. When you have a triangle, if you have a ratio of angles of 5 to 9 to 16, that means that there's some value being multiplied to each one of those angles that's the same. We always just call that x. So if you have this thing called an extended ratio, which you'll have it in terms of angles, you'll have it with perimeters, you'll have it for a whole bunch of stuff. If you see this, just remember, all you have to do is just put an x next to the numbers. In this case, put all 3 angles at half equal. So it's become super, super easy. It's just different words to make it work. Okay? So when you write it out, you get 5x, 9x, 16x, What's 5, 9, and 16? There you go. And that's what I was saying. I figured I'd give you the first part, but I didn't think you would take that one. Still have the animals on it. Yeah, that's fine. I didn't think you were going to Thank you, man. So 5, 9, and 16 is how much? Oops. And then x is 6. Now, again, is it asking you to solve for x, or is it asking you to solve for something else? So you get x is 6, and just like on the test and the final, that just means you're just substituting it. Oh, I forgot to ask you guys. What did you guys think about that multiple choice and the short response thing? How'd that work out? The thing that I've noticed, and that students, you know, most of the people I've talked to about it thought it was pretty decent that way. One of the things that I know you're getting at, I know where you're going with it. You're like, this can't be right. This is. One of the things that we noticed, Fontana and I are the ones that teach the 2 regular geometry classes and stuff, and we have 6 of them between the 2. What was nice is that by doing that short answers part to it, it quite literally curved the test basically on its own, because of the 1.2 point values out of those things. What I saw when we were doing the distribution of all the different grades that we had on it overall, you can see a very distinguishable chunking in the different, where the grade marks would be, you know, A, B, C's, and D's and whatnot. And it was very evident where those breaks would have landed, as opposed to in years past, we'd have to fudge with some of the numbers and work with the curves and try to see how many points if we go back and forth was valid and all that. But I think Seb had it hit the nail on the head by doing the test that way. It really did turn out to be a really nice test. And it worked out that way also for my honors class for my Algebra 2 kids. So, I'm sorry. Anyway, so what do you get? 54, 30, and not 54. Yeah, 54, 30, and 96. Oh, new people. I never go off on tangents ever. We talk about stupid stuff. Like I was saying earlier, some vocab that'll come back from first semester and second semester, you'll still see supplementary and complementary. So it says 2 supplementary angles are in the ratio of 1 to 4. What do those 2 have to add up to equal? 180. Okay. You're just waiting for somebody else to answer. Yes. If it said complementary, they'd have to add up to equal how much? 9. So it's those little subtle things that do come back with the vocab that you'll see over and over again. So if I'm writing the 2 angles that are supplementary in the ratio of 1 to 4, that means when I write it out, it's going to be 1x and 4x equals 180, because it says supplementary. You're using the different parts of the vocab to set up the algebra. Again, this is not anything on chat, so it should be. So deep breath. 1 plus 4. You get 36. You got to figure out the 2 angles. One of them is 36. The other one has to be a number. You're right. More than 36. Yeah. And 144. And who's ticking? Who's that? What? Oh. There's a bomb on the bus. It's gotta go one. We gotta go 55. Was that speed? Is that speed, right? bad. What year was that? What you got your phone out because you know you never don't have your phone out. Check it. What year is that? I want to say it was 96. Look it up for me. I want to say it's 96. That was the mid Keanu Reeves days. No, Speed wasn't in 2012. There's another movie called Speed. For 2012? No. 94, okay. 1994. I was close to the 96. 2012. No, there was another Speed because it was on a cruise ship. Yeah. All right. Does anything change when they talk about perimeter? Triangles have side lengths in a ratio of 3, 5, and 6. If they tell you that the perimeter adds up to 98, what do you set your equation equal to? 98. It's the same basic thing. What's going to happen here, guys, is that you'll get accustomed to doing the problems over and over again. You're going to always think, oh, it's a triangle. It's 3 sides, 3 things. It's going to equal 180. You have to read. Are you talking about sides or are you talking about angles? In this case, you're talking about sides because they're talking about perimeter. So you just got to be careful with it. It's just a quick little dumb mistake that people tend to do. So go and figure that one out and then figure out what's the length of the longest side, please. Okay. Gonna make fractions of that? Alpha y equals. What is that? 11, 14? So how do you know which side length should be the longest? So what's actually kind of crazy is that right now, if you have your sides of 3 times 7, 5 times 7, and then 6 times 7, you've got your 21, 35, and 42. That gives you all your side lengths because you just work with the ratios. In about a month, I'd say, we'll actually be able to take a triangle that looks like that with just the sides, we'll actually be able to figure out all the angles then too. Once we start going into, once you start getting into trigonometry, if you know specific values and certain things, you can actually, in this case, we can use what's called the law of cosines, and you can solve for the largest angle. What would be the largest angle across from what side? The 42 one, 6x side. And we can go and do all that. So as we go along, we're just using this real basic quick algebra stuff, but eventually we'll be able to do, I won't even write it out, so just mess with you. You'll be mad at me. Do I need another triangle one? Science. All right, Joe, this one's for you. Triangle sides, 4, 7, and 9, perimeter 60. Find the side lengths. And make sure what are you going to do with that water bottle? You're not going to leave it lying around, are you?
Yeah, I'm going to take it with me.
been retired since you were he was at Buffalo and well, he lived there. So Buffalo Road was probably about 4,000. So this is like small to you, but yet you probably didn't have 36 in class. Yeah, it's a little different. Our building's a little different. You have probably got new phone number that you have. We'll get the homework that I have tonight. I'll take a picture of your phone. Assuming you probably have one, just fun. I don't think I don't anymore. Otherwise, I'd send you a quote. But
I just got one.
there's no problem, you know.
And it is a thing or
Whatever.
really.
It works. So again, math is mathing, and it's not that bad. What do you get? 3 total, I think. You get 20. What's the answer? So you get sides of 12, 21, and 27. Pretty easy. Now, the other part of this chapter, or this first section, is stuff that you guys have also seen. For example, when we talk about ratios, if I said that it was 8 over 10, what did that simplify to be? 4/5. Now, we've done this before. Remember the tail end of first semester, we had some fraction equal fraction problems where we just change things on the diagonals? Remember I showed you guys so you can just flip things along and nothing changed? Like, if I exchange these two, 8 over 4, isn't that the same?
Oh, yeah.
It means the same, yeah, well, what's 8 divided by 4? If I flip them back the other way here, you get 5/4, 10/8. The reason that that happens is because whenever you have equal ratios, they're called proportions. So a proportion is 2 ratios. You can say 2 or more. So proportions, when things are proportional, means they have the same ratios. It means they have the same what we call scale factor. And it works out really, really, really easy. This is where we check what are called cross products. You guys remember that term? No? What's cross products? Cross products means, well, what's 8 times 5? 40. What's 4 times 10? 40. Does 40 equal 40? That's why you know that they're proportional. When you cross multiply fractions like this, if you get the same thing on both diagonals, that means it's a true proportion. If you don't, it means you've done screwed up or they're not. It's really, really straightforward. And that's where the whole idea of cross multiplying to solve for x comes in, which we did at the end of last semester. So we got into stuff like this. We did a whole bunch of quick math problems to solve for x. Vaguely remember that? Oh, we did. We had it written out a little bit differently because we wound up with, we were setting things equal to each other and you wound up with a fractional account. And it works the same way. So if I'm going to solve 6 over 7 equals 30 over x, I'm just cross multiplying to solve for x. Okay? All you're doing is figuring out what that is. Divide that out. Excuse me. Super, super easy. What do you do for the other one? You do the same thing. All right, figure it out. And sometimes it's a shortcut. Sometimes there's a nice shortcut. When you have fraction equal fraction, you can actually just rather quickly, I should say. Watch what happens. 6 times what's 30? 5. What's 5? What's 7 times 5? 3 times what is 9? 3. What's 7 times 3? You can use shortcuts like that. Otherwise, if you want to multiply out, it works the same way. But if you recognize it, cool, go for it. There's nothing wrong with it. Shortcuts in math are great, especially if you do them correctly. If you don't do them correctly, then you're screwed, and you're going to get the wrong answer, and you know, very, very sad. Speaking of sad, hi. That's a joke. What'd you do to your foot? Thanks. I couldn't figure that much out. Did you like stub your toe, or did you like roll an ankle, or did you kick somebody for being mad at being mean? Oh. No, just how she said it. She said it just so stone-faced. I'm sorry, I didn't mean to laugh, but just how Miss Jackson said it was just pretty funny. So the only thing that's going to be a little bit weird with this, that you have to be careful, is when you have problems with like this. This scenario is one that most students, you can do that without a big deal, but most people will make a dumb mistake. Okay? So whenever you see cross products that you have to cross multiply, and you have a variable with something tied into it, make sure you put it in parentheses to distribute, right? Because so many times when you get to this part is where you'll make a dumb mistake. It's 3 times the m plus 4 equals 15m. You have to remember that you have to distribute that 3 to both parts of the stuff in the parentheses. It's a hugely forgotten thing. I had a question on my honors algebra 2 final that was very similar to doing something like that even those guys still forget to do that. So take 2 seconds. Draw those dumb little arrows going into it just to remind you to do that. Move that around. Divide out. And you get a 400. You want to flip over. Again, we're mathing here that isn't extraordinarily difficult mathing. Right? And I'm going to go through all that. All right. I'll give you some stuff. I'm telling you, this first section is pretty quick. We'll do a lot more algebra stuff between 7374, or sorry, 7273. So, what is this? So guys, I'll put this up there on the board for you in a second. It's really quick stuff. There's not a lot of crazy thrown into this to start out with. Tomorrow, as we get into it, we start talking about what are called similarity statements. And that's where things become a lot more, I don't want to say complicated. Yes, ma'am. Yes, ma'am. When we get into stuff tomorrow with what are called similarity statements, it kind of mirrors the idea of when we did congruency statements, where you're able to tell what angles match up and things like that. Well, when we have a similarity statement, we'll be able to tell what type of sides match up for the ratios. It's super easy, but you can get kind of mixed up on it if you're not careful. So, do you guys have that written down? No. What's up? Okay, one of my dads. Here's those first handful. If you guys want to get started on that, please do so. This should not take you very long to go through.